So I think we're talking a lot about like, so this one use brute force, so this one use two sum. So you combi both of it, you get the answer for this. So and I think one thing to actually take note is that you can also do some over here, and then the brute force at the C. I feel like it's fine as well, but intuitively for this problem statement, I feel like they did it this way, brute force, do some. In my opinion, it turns out to have like the same result per se. I'm not too sure like for the duplicate, how do they actually solve it? Maybe they can use a headset to say that if that value it's already been synced, you can't insert it again. I think this is one way. I think the second way is that you kind of like compare the values adjacent, because the first thing we did was sort. So after you sort, you just keep on comparing the adjacent value, I would say. So compare this, are they equal? Okay, they are equal, then we remove one of it. Compare, not equal, fine. Compare, kind of like rinse and repeat per se. Um, um, and so like just run through. So we brute force, right? So we got the first value, and then we have the L and an R. So for L, right, per se. So I mean, you move over here, it's gonna be positive. So you move here, it's like you are increasing, and then from here you go this side, you're kind of like decreasing the value. So first one we check, this one is 1, it's like a positive 1. So is this equal, when we compare to -3, do we get it? Is this too small, too big? Too small, right? We want to add even more, so we take the positive route. So L comes here, and this time around it's 1 and 4. It's like 5. So right now it's like too big, right? So we want a negative, so our R comes here, 3 and 1, 4. So it's positive 4 right now. Now this one is like too big, right? So we shift R to here again. So L and R, this time around is 3 and 3, and then you get a 0, and this is the correct answer. So you have 1, this L, this R, and then the brute force, the first one. Just nice, the first brute force, we get the answer. So brute force is like there's like a possibility you go for a negative 3 set, a negative 3 set, this 1 set, this 2 set, this 3 sets. And obviously if you were to actually go to the 3 sets, your L will start from here, your R will start from here, and you kind of like start to do the same procedure, you rinse and repeat. So at the very start, they did do like a very naive way of like the approach. So I mean, it's A, B, 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 and C, right? So this tiny got the answer by coincidence. Is it like this? Or they can even move forth. So as you can see, I don't think you get the answer for these ones. You kind of like keep on trying, and then you start to see some sort of like pattern, what not have you. I don't necessarily know like why we weren't able to actually witness him actually trying to brute force it this way, because either ways it gets really confusing in my opinion per se. But I mean the thing about just on how he explained was that it just coincidentally like land onto the answer at the first naive way, which is the negative 3. We have this value, this and this, which add up to 0. Just very coincidental, and then we didn't get to actually witness him to actually do more brute force, so that's pity. But I just feel like whatever I just rinse and repeat previous was pretty much how you actually do the brute force way for this question per se. I mean, I just feel that this stage 1 and this stage 2 and per se is this one is referring to our two-sum solution, and this one is our brute force. I think that's why I mean, like if I were to actually, you know, reverse engineer from the big O times square, so it's n squared, right? So this is n and n, and I feel that if you do brute force, you're just running through every single value. So you are checking this, checking this, and I'm talking about stage 1. And stage 2 is also n, because you have one L, right, and then a R, and then you kind of like close in, and close in. So it takes another n. Brute force, it takes n, right? So this one is stage 1. You take n, right? You run through every single value, one by one, and then for the stage 2, you technically also run through every single one of them. And we're not talking about like saying that your two sum is like n squared, right? because if it's n squared, it means that around this time, maybe say here has 1 2 3 4 5 6 elements. It's not gonna like be 6n, in the sense that your L pattern, it just need to go one time good one wave, and that's it, which is n, as opposed to you having need to check then no, you don't do that. You just one sweep. That's the beauty about two-sum, in my opinion. It's a one sweep thing, and I believe that this brute force one is also like one sweep. You just check one time good one. But then again, is that for each brute force, there's a set of two-sum. That means, if say I pick a -3, right? There's like a multiplication of like a two-sum. We conduct a two-sum here. We pick another -3. We need to conduct a two-sum again. We pick a 1. We need to conduct the two-sum again. We pick a 2. We need to conduct like a two-sum again. So each of the element, we do a two-sum after, and yeah, I mean, so So yep, everything comes to an end.